Professor Bright here, and we're going to go through an example for week 3. So just as a reminder, in this week's videos we focused a lot on different style tips within mathematics writing. And so make sure that you have a chance to review those videos and maybe take some notes on them before watching this video. Okay? So we are going to go through an example which discusses which uses rather the intermediate value theorem as part of its solution. Okay, and what we're going to do is focus in this example on the different mathematical writing pieces that we discussed this week in the videos. Okay, so I have an example here that I chose from textbook from 2.4 or from section 2.4, number 41, and okay, so the entry is already started for us, so again, recopy the original problem, and for time purposes I'm not going to write out the entry with all of you, but remember that you should make sure to identify the goal of the problem, identify any additional assumptions you need, okay, and just a note on that, the assumptions here that I'm thinking of are not necessarily the same as the assumptions and hypotheses that I was discussing in an earlier video. Okay, so this would be we need to assume this in addition to everything else that's already been given to us. Okay, so here there shouldn't be any additional assumptions required, and then we're also going to overview the process. Okay, the process to be used. So maybe here you mentioned the IVT, the intermediate value theorem, maybe you need to create a function f, etc. Okay, but I am going to jump right down to the attack. Okay, and so in the attack, this is again where we start problem solving. Okay, so what I'm going to do first is I'm going to say I need a function. We define function f of x as, and then now this is a function on its own, so f of x, and I'm going to use the left hand side of the equation, so x to the fourth minus x, or plus x minus 3, okay, and include a period, okay, correct punctuation, okay. And then next, this is all style tips or style preferences at this point. To illustrate some aspects that we talked about in the videos this week, what I'm going to do next is I'm actually going to make a graph. Okay, so I'm going to say the function graph is visualized below. Okay, and I did this already in Desmos. Okay, so here's what it looks like, and so I would have this maybe as a reference, but I'm actually going to choose to kind of hand draw it to the best of my ability. So it's going to have a y-intercept at -3, and then have different x-intercepts between 1 and 2 as desired, and between -2 and -1. Okay, so I'm just going to do my best to do a quick sketch. Again, if I was actually submitting this, I would take more time to produce a good drawing. Okay, so this is my y-axis, and this is my x-axis, and I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, and I need to make sure to label a scale here, so this is -1, -2, -1, -2, and so we said it had, and then this is 1 and 2, so it had a y-intercept, or x-intercept rather, right about there, went down to -3, and then it did a little wobbly thing and did something like this. Okay, and then as illustrated in the video, I'm going to label this with a caption, graph 1 graph of f of x. Okay, and then I would continue below, and I'll say, based on inspection, we believe the statement to inspection statement to be shown is true. Okay, and so I actually want to add something in here based on inspection of graph 1. Okay, making sure to refer to it. Okay. And now, so what I've kind of done here is I have two different pieces. I have the function defined. I have a visualization of it, which again, you don't have, I won't necessarily need to include per the instructions of the problem, but I did, and now I'm going to go on and do the calculus or the algebra components. Okay. So now we show the formal existence of a root through the intermediate value theorem. Okay. To use the intermediate value theorem, and yes, I'm going to write it out every single time. Value theorem. F must be continuous on a closed domain, and its range values at each end of the domain must be found. Okay. And now I'm just going to go through and verify those one by one. Since we know f is a polynomial function, it is continuous. Okay, and this is actually a result continuous from the textbook, and I'm actually going to cite the property from the textbook that uses this, and just referring to that here in the textbook, that ends up being Theorem 7 by Theorem 7 in section 2.4. Okay. Also, oops, let me back up here. I made a mistake. Okay. Now, erase this. Alright, so the next part, if this goes away, is to, okay, well, we're just going to scribble that out. Okay, so the next part is to show that it's on a closed domain. Now the problem, if you actually look back on it, it actually is on an open interval, right? 1 to 2 open. However, that's to show that there's a root in there. So we can actually say, we can expand the domain of f to be 1 to 2 inclusive. We consider the domain of f to be 1 to 2 inclusive on both ends, and oh, that just deleted. That's okay. Everything's deleting. Okay, so that was a little unexpected technology issue, so I apologize for the brief gap or the different screens that you might be encountering right now. But so we left off just a little bit ago with talking about the continuity and how we can actually take the domain to be just a little bit larger. Okay, so we consider the domain of f to be that, where, and then f of 1, okay, if I evaluate f of 1, that would be 1 to the 4th plus 1 minus 3 is negative 1, and, okay, f of 2, okay, so 2 to the 4th is 16 plus 2 is 18 minus 3 is 15. Okay, so, and then I just make sure to include the period, and you don't need to circle it. I'm just doing it to demonstrate that it's a part of a sentence. Okay, here, this is a bit of a style thing. I personally choose to put any evaluations on their own line, just to make things look nicer. Okay, so to use the IVT, I have to do continuous, closed domain, and the range values are found. Okay, so now I can say that since, and actually this is, I would probably reword this eventually, but we'll get to that point in a minute. So since f of 1, and let me actually put this on its own line. Since f of 1 is equal to negative 1, which is less than 0, which is less than 15, which is equal to f of 2, okay, comma, and all conditions, or rather hypotheses, of the IVT, well, intermediate value theorem, written out, oops, let me go back here. Have been satisfied by the conclusion of the IVT, intermediate value theorem, intermediate value theorem, there exists a value C in, and I shouldn't use, I was about to use mathematical shorthand, we're not going to do that though. In 0, 1, such that f of c is equal to 0. Okay, this means there is a root root of f in the given interval. Okay? And that satisfied, so if we look at the entry, show that the given equation has a root in the specified interval. Okay, great. And so I did that, and that would lead me into my conclusion. And again, I'm going to let you write your own conclusion to this. But effectively, what you have to make sure to mention is do a summary. This is the reflection or conclude and reflect. I forgot about the reflection part. But the summary and then the result, and then provide a brief little reflection where you connect ideas or identify something that was really surprising or challenging to you in the process of solving this problem. Okay, and the one note that I was going to mention here, just so I had underlined this since up here. If you notice, and this is just a style thing, the preceding sentence started with since, and, well, I used since recently, actually, so this was the preceding sentence, but I would like to try to avoid starting sentences with the same word as a general good practice in writing. Okay? So this was an example, hopefully, that illustrated some of those aspects that we talked about in this week's videos.